have just taken up the pathogenesis and morphology and other things. So today we will talk about the laboratory isolation and the lab diagnosis. Actually, the lab is taken by the female side, girl section not there, so we decided to take over section here. Today we are going to talk about the staph, Clostridium perfringens, Bacillus, species Ganasirus, Helicobacter pylori, previously known as Campylobacter, Salmonella typhi and Paratyphi, bacteroids and Listeria. Okay, so let's start from one by one. Staph, almost all of you know, because right from the first year you are gram positive and gram negative. Staph aureus, it is a gram positive. The microbe, when you see under the microscope, it's like a grapes, a bunch of grapes in a clusters. We have different strains for Staphylococcus, like Staphylococcus aureus, Staphylococcus epidermidis, Staphylococcus saprophyticus. Okay, all of them they call the pathogenic strain Staphylococcus aureus. However, when they saprophyticus and other epidermidis, they get a chance and they can also cause an infection. So here we need to talk about Staphylococcus aureus as it causes the food poisoning, right? It causes food poisoning, yes or no?
Yes.
Yeah, it causes the food poisoning and also causes the pus. So sampling, it depends. You can take a homogeneous food from the throat sample, nose or wound. So it depends to take the sample. When we see under the microscope, as I said, it's a bunch of like grapes, like structure, and it's a non-motile. However, two tests are very important biochemical tests. Coagulase test and catalase test. What is the coagulase test? Yes, Staphylococcus aureus, it produces the coagulase enzyme. The coagulase enzyme that has a capability. What coagulase do? It converts the coagulase fibrinogen into the fibrin. Fibrinogen is a soluble present in the blood, and it gets converted into fibrin through thrombus. Then it clots at the time of injury. However, when this microbe is present in the blood, it can release the coagulase enzyme to protect itself and it forms the clots. So it gives a type of protection to the Staphylococcus aureus itself. Okay. Second is the catalase. What is the catalase test? Catalase test of Staphylococcus aureus, it is a catalase positive. It breaks down hydrogen peroxide into water and oxygen. This is the principle. The principle of catalase test is breakdown of this is step for breakdown of the hydrogen peroxide. The catalase enzyme released by the microbe, it breaks down the hydrogen peroxide into water and oxygen, because hydrogen peroxide is a free radical inside the body. It causes the damage and it also protects it. At the end, it can kill the microorganism. However, this microbe is a protection. When H2O2 approaches to kill this bacteria, the bacteria immediately releases the catalase enzyme and protects itself. Free radical gets neutralized. Similarly, for coagulase test, here it's the tube test. Actually, coagulase we do in two, in the slide as well as the tube test. What is the difference between slide and the tube? Yes, please.
Slide tube.
There are two tests step orders. This means that if we do on a slide test, there is direct clumping without any roll. But when we do a tube test, it is called, but we use the first word, clumping releasing factor, right? You said in the beginning. So clumping, some staph, sometimes it produces the clumping releasing factor. It reacts with the fibrinogen and causes the formation of the fiber. So in the slide test, it is directly conversion of fibrinogen into fiber. Direct test, direct in the slide. However, in the tube, first clumping reacting factor reacts with the fibrinogen and converts. This is the difference between tube coagulase test and slide test. So this means whenever in the lab we diagnose this Staphylococcus aureus, we do the immediate test on we are doubtful about this test. So we keep the tube test for whole night in the incubator. Next morning we see if it is a clogged yes. He did the conversion of fibrinogen to fibrin with the help of a clotting release effect. This is called the tube test.
So tube take more time.
Tube take more time. Because why? It is indirect method. First fibrinogen must get attached with the clotting releasing factor by the staph, then converts into fibrinogen. But sometimes it directly reacts in some of the tests. Yes, and the slide test. Fine. So this is about the microscopic observation of Staphylococcus aureus and its biochemical test. Two biochemical tests: catalase and coagulase, and microgram positive. And next we will go for its culture. The culture Staphylococcus aureus, when it is grown on a blood culture, beta hemolytic. Only two things remember: beta hemolytic and golden colonies. And two things. Beta hemolysis complete and golden colonies and not yellow. And gold. On blood agar. You will find large round golden yellow. You can say a golden. Golden yellow means golden, eh?
Yeah.
Large round golden colonies will complete hemolysis. Hemolysis, okay? On the blood. And this is the reason Staphylococcus aureus. Aureus is a word.
That's it.
Gold.
That's it.
Yes. It's a Latin word obtained from its color gold. And why this gold color is produced? I told you in the first year.
Yes.
Why it is gold color? Because of pigmentation of Staphylococcus aureus. There are special genes in his DNA that produce this pigment. This is about the blood. So what is the properties of the blood if we culture Staphylococcus on a blood agar? Whenever we culture staph on a blood agar, there is beta hemolysis and there are gold and yellow colonies. Colonies. Next is the MR assay. Mannitol salt agar. If we see other strains of Staphylococcus like epidermidis and saprophytes, they do not grow on the blood agar. So they grow, but there are no golden colonies. Okay. Now here, to confirm this test, again, because you want to prove that this is the Staphylococcus aureus, you put up one more culture media, mannitol salt agar. What's the mannitol? What's the mannitol? Mannitol is a sugar. Very simple. Mannitol is a sugar.
It's wonderful.
So mannitol salt agar. This is a sugar media containing sugar mannitol, but it contains salt. It contains how much percent? 70 to 10%. Because why? Most of the pathogenic strains, they do not grow on the higher salt concentration. Usually 3 to 4%. After that they die. They cannot grow. But when you talk about the Staphylococcus aureus, it has two features. It grows on the high salt and it utilizes mannitol as a sugar. So here it is a yellow color. This yellow color is due to? No, not the pigmentation. Now here, yes, fermentation of the sugar. The fermentation of sugar decreases the pH. In this case, on blood agar, it produces this means blood provides some special nutrition to the Staphylococcus aureus, pushes its ribosome to synthesis a protein that acts as a pigment on the blood agar. But the same staph is grown on the mannitol salt agar. At that time, there are no pigmentations, but there is a fermentation of the sugar. There is a fermentation of sugar is a mannitol. This means at a higher pH, when sugar is fermented, acid is produced. Okay, it depends. Sometimes acid, sometimes base. Usually acid. In this case, acid is produced. When acid is produced, the pH goes down. And medium becomes the acidic. This culture medium becomes the acidic, and there is presence of dye. The acid reacts with the dye, and it will use the yellow color. Clear?
Okay.
Finished, step?
Yes.
Any questions? So we have two type of culture methods: blood culture
Mannitol salt agar.
Mannitol salt agar. Why mannitol salt agar is a two features. It contains mannitol and higher salt.
Salt.
High salt usually restricts the growth of other bacteria. Okay.
Yes.
You see stem, it has grown here, but it is not capable to ferment mannitol. Stem it did not ferment. Here it ferments the mannitol. Fine. So let's go to the next. Clostridium perfringens. So what are the Clostridia? What are the other strains of Clostridium? Yes, Fahad? Clostridium difficile, okay. Clostridium botulinum, very good. And Clostridium perfringens here. Okay. And Clostridium tetanus.
Tetanus, yeah.
Very important. Botulinum causes food poisoning, tetanus causes tetany. What is the tetany disease? It makes your muscles stiff. Sometimes your muscles go so hard it can break your bone. Sometimes when tetanus clostridium affects very badly your body, the muscles of the body, it makes like a bend and sometimes it may break the bones. So, but here we are concerned with Clostridium perfringens. We will see it's how we can isolate this microbe in the laboratory and how it can be differentiated from others like Clostridium tetani, like Clostridium botulinum. Okay, because you have a Clostridium, and then there are Clostridium is a genus.
Yes.
And these are the species. Perfringens is a species, botulinum is a species, tetany is a species. However, there may be other strain types. How many strains of Clostridium perfringens? A, B, C, D, E, F, G, H. Right? You had a lecture on it? Maybe you have. Okay, there are a number of its own types within the Clostridium perfringens. A, B, C, D, and so on. So let us see about this microorganism. You need a food sample or a necrotic tissue. It's the gram positive, very clear rod shaped,
Yes.
and anaerobic and catalytic, but it's a non-motile. Catalase positive and oxidase negative. This is catalase positive, oxidase negative. What is catalase positive? Same. Breakdown of hydrogen peroxide into water and oxygen. What is oxidase negative? Cytochrome. It's an enzyme. Enzyme oxidase is an enzyme present in some microbes that help them in their respiration. It accepts the electron and transfers to the electron transport chain inside the bacteria and transforms into water and energy. And electron is used for respiration. Culture. Robertson's cooked meat, RCM, Robertson's cooked meat. This is an ideal medium for the growth of anaerobic bacteria. Anaerobic bacteria. What are anaerobic bacteria? Those bacteria that grow in absence of
Oxygen.
So do not confuse yourself that Robertson is only for Clostridium perfringens, okay? It's in general a media for anaerobic. However, it's also it's an ideal media for the growth of Clostridium perfringens. Clostridium perfringens. When you see this picture at a home, you will see here pink coloration, okay? Here it's not seen, but when you see on the phone or somewhere else, you will find a pink colors. Two things happen with this robot. In the Robertson cooks meat, it's a media containing pieces of a meat. Lamb's meat, cow's meat, buffalo, whatever meat pieces are here. And you inoculate it with Clostridium. You inoculate with Clostridium, not perfringens, Clostridium. You do not know.
Yeah.
Next morning when you see, if color is pink, if color is
Pink.
if color is
Pink.
pink, then it is Clostridium perfringens. If color is pink, it is like here. If color is black, I am sorry, it's not visible here. Actually, it is pink. And if it is black, then it is theta.
Theta.
Now, question is why black and why pink? Your answer.
What?
Why it is pink? Same media. Use it for anaerobes. Next morning, we see two different colors. One color is pink and one color is black. Why this pink and black color? What's the reason?
Utilizing chemistry or
In case of a pink color, what is pink? Pink color is Clostridium.
Preferences.
This means this bacteria utilizes in the meat only sugar.
okay.
This means
Utilize ownership.
utilize only
Sugar.
This means Clostridium perfringens is saccharolytic. Clostridium saccharolytic species. Turns meat saccharolytic and eating only sugar.
Yeah.
They have nothing to do with the other things, fat, protein, blah blah blah. When you talk about the black color, if meat turns into black, this means the bacteria is not having the capability to take the sugar. It takes the proteins from the meat. It takes that.
Protein.
And protein, when is utilized by the microbe, the color of the meat
Yeah.
changes into that
Black.
black. And example is masalan, Clostridium tetani. Okay, Clostridium
Theta.
proteolytic species turns meat into black. So this is the difference. Because Clostridium is the same media is used. That's the reason in the beginning I told you Robertson cooked meat for anaerobes. However, it is an ideal media to see the Clostridium perfringens bacteria. Why? Because this microbe changes the media into the pink color. Into the
Pink.
color. Why? Because it uses it as sugars.
Sugar.
You see, if you go at home and read this line, you will find what I am talking to you, you will find the content here. In the meat turns pink without the digestion. What does mean without the digestion? Without digesting of proteins. Without digesting of protein. The sugars are utilized. So clear?
Yes.
Robertson cooked meat, it can be used for the growth of the Clostridium species. Depends on the coloration. If it is pink, then it is Clostridium perfringens. If it is black, it is a tetani. Here, it's only pink. Black is not, because it's not required for it. It's just to make you clear difference between the two. Fine?
Sure.
Yes, yes.
So can we use it with other genus?
I said anaerobes, yes. Anaerobe means it's not only Clostridium.
The same result with color?
No, it depends. It varies. It varies. Yes, it's very important. Varies. Pink for Clostridium perfringens. Next. Now, another test, it is called a natural reaction. It's called, who was a natural? It's the academician or the scientist. He was a person and he said, okay, now you in the laboratory you find the microbe, it's rod shaped, you find it's the pink in color, you see that it's the Clostridium perfringens. He said he discovered one more test. He found one more test. And the toxin by this microbe is produced, it is called alpha toxin. It secretes alpha toxin. What it secretes?
Alpha tox.
Alpha toxin. Alpha toxin secreted by Clostridium perfringens has an enzymatic activity. So this means it acts as an enzyme. What is the lecithin? You heard this name?
Yes.
Where it is present?
Plastic.
Where it is present? No, it's not a bacteria. Our cells, they are made of membranes. Human body cells.
Yes. Human lecithin.
Yeah, lecithin is a component of the cell membrane.
Yes.
Lecithin is a component of. Forget about the natural reaction and lecithin or alpha toxin. First, lecithin is the component of cell wall present in our cells.
Yes.
Billions and trillions. Each cell has an outer covering, plasma membrane, okay, or a cell membrane. This membrane composed of what? Cell membrane composed of what? Lipid. Very good. Those lipids are called as
Phospholipids.
Very good. Phospholipids. And if you see the phospholipids, they are like this, right? the membrane of the human body of plasma and cell membrane, it is a double layer of the phospholipid, okay?
Bilayer.
So this is the membrane. If this is the cell of human body, this is the nucleus, ribosome, other thing. If we see the part of this membrane in open way, you see the phospholipids. Inside the phospholipids, one component is lecithin. One compound is lecithin. And first, this compound, when you had a lecture, you will find it. This lecithin first was found in the egg yolk. Egg yolk, yellow color.
Yes,
First
okay.
it was found there. So what he saw when he cultured the Clostridium perfringens on the media containing egg yolk. He make a culture of media, sugar, ammonia, and he add egg yolk, egg yolk. This egg yolk contains lecithin. It is the component of cell membrane. Similarly, egg and its the structure is same, right? What he saw there happened an enzymatic activity. What activity? The microbe releases an enzyme,
Finese.
lecithinase.
Catalyze.
Releases an
Lecithinase.
lecithinase. Then when it is an A means enzyme, this means it has a capability to break down this phospholipid. It breaks down. When the phospholipid is broke, what will happen? The cell lysis will occur immediately. So this lecithinase, when he found this, it is a toxin, alpha toxin. He called it as an alpha toxin or Clostridium perfringens. Actually, the formed by group A or type A of Clostridium perfringens bacterial strain produces the alpha toxin, which is a lecithinase, where it is here. So alpha toxin, it has an enzymatic activity. This alpha toxin is present in the Clostridium perfringens when it is grown on a media containing the egg. Why egg? Because egg contains the lecithin part of a membrane, of a cell membrane. The microbe releases this enzyme, and it causes the breakdown of this. It causes a breakdown. And when you see that breakdown, it causes a breakdown. It breaks the component of the cell wall. Component of cell wall is lecithin, okay? And when it breaks, it is like this, cloudy thing. You see, this is the strain. This is another strain, Clostridium sporogenes. There is no cloudy structure. Here it is a cloudy structure. Here no cloudy structure, no cloudy structure, no. I will talk about this part. This media is divided into two parts, okay? This media is divided into two parts. In this part, this media contains egg and material. When Clostridium perfringens grows, it makes cloudy structure here. This is called Naegler's lecithinase test. When lecithinase enzyme releases by the bacteria, it breaks down the lecithin and this cloudy structure is formed. When we see Clostridium sporogenes, it grows on the same media, but there is no activity of lecithinase because this is absent. Alpha toxin is absent in sporogen. It is present in it is present in Clostridium perfringens. Actually type A, there are many types. Now what happened to this region? If this is covered, why not this? Because in order to confirm the test, we divide the media into two parts. Divide the media in two parts. In this part, we add antitoxin. We add?
Antitoxin.
What's the job of antitoxin?
Neutralize the alpha.
To neutralize the enzyme. See here. I have made this circle. This is the culture plate, okay? We divide it into two parts. It contains the media. Media usually, what is the bacterial media? Sugar, amino acid, vitamins, minerals, everything. And we added egg. We added egg yolk in this whole media. We divided the media in two parts. Okay? Here we add antitoxin. Antitoxin. Antitoxin actually is an antibody that blocks the activity of lecithinase. Antitoxin is a substance in an antibody that blocks the activity of lecithinase. So when this is the Clostridium perfringens whole bacteria, it grows, but it allows the growth of the bacteria, but it does not allow the lenticinase to act on the cell wall. Why? Because it is blocked. For example, bacteria release enzyme.
Yes.
Immediately, antitoxin comes and cover up it and utilize it. So there is no reaction. There is no.
Yes.
On the other side, from this way, Nadler got that year one of the best awards in the academics. He proved that bacteria produce lenticinase. He said if antitoxin is used, activity is inhibited. Okay, and it is seen here in this test. This is called the natural overall palate. This is the media. This media contains the contents for the bacteria utilized as well as antitoxin. Antitoxin we put on this side, left side, on right side. It's the media containing the aereo. Here also, Clostridium perfringens grows only on this part.
Yes.
Grows only on this part. And we have to make sure while adding the antitoxin, it should remain only in this part. If it goes on this side, you will not find any result. It should be here, focused in a particular area. And next day, when you saw the lab results, you saw this is the component is broken down in the cloudy formation here. And this microbe, it has shown the growth, Clostridium.
Yes.
This is Clostridium, this is Clostridium. Both can use the same media, but difference is the presence of the toxin, either present or not. The toxin is present here, alpha toxin here, it's not present. Any questions? Clear? Finish. You see, the effect of lenticinase on alpha toxin, it is inhibited if antiserum containing alpha toxin is present. It's alpha antitoxin against it is present. Okay, boys. Bacillus. Bacillus cereus, Bacillus subtilis, many strains of Bacillus are found. Right? Even, I did the research in 2013 here in the Doma lake. I found 9 new bacteria of Bacillus. How many?
9.
9 new. All are published now along with their DNA sequences in the PubMed. But all of the 9 were found non-pathogenic. Were found in the Doma lake. So this is the Bacillus family. This is the Bacillus. And cereus, Bacillus cereus also cause food poisoning, right? About this, it is a gram-positive, non-encapsulated motile, catalase positive, oxidase negative, and on blood agar, the only thing about the blood agar, very thick colonies, very big colonies. You see about this. That's it about Bacillus. Very simple, nothing special. Grow. On Bacillus cereus, you grow it on the 5% blood sheep agar, you see gray color of colonies, opaque, yeah, they are opaque, they are granular and with irregular pattern. I mean irregular means they are some very small, some are very big. And
Second or
opaque. What's opaque? This is opaque. I cannot see clearly. If I remove this, it becomes transparent. Okay? Clear Bacillus cereus?
Yes.
Clear? Helicobacter pylori. Look, every microbe has its own specialty, own special features, own special toxins, either exotoxin or endotoxin. We're not going into the detail. Some microbes have special enzymes like the Clostridium perfringens, lenticinase, alpha toxin, enzymatic activity. So it is not necessary that all the toxins have enzymatic activity. Remember this. All toxins, it is not necessary all toxins are enzymatic in nature. Yeah, they work as an enzyme. But here in the perfringens, Clostridium perfringens, alpha toxin has an enzymatic activity. Lenticinase. Similarly, Helicobacter pylori, God has given him one enzyme. Which one? Urease. Very good. That is very rest is okay. It's gram-negative bacteria. Here you see in your stomach it is present. What's microaerophilic? Microaerophilic. This means even if
low presence of oxygen.
low percentage of oxygen, correct. It's highly motile, this microbe, okay? Catalase negative, oxidase positive, but it is urease positive. What is the job of urease?
Urea to ammonia. Breakdown of the urea and water to ammonia and carbon dioxide.
Very good. Now you are very smart with the third layer. Shall I remove this? alpha toxin activity, finished.